got okay, thank you. Just one sec. We'll start session and still waiting for some other partner. Still, yeah, Praveen, I'm audible. Okay, please write me in the chat window. You can start the session. Okay, thank you. So, okay, just one. All right. So, welcome you to Prwatech Hadoop online session. So, not now, Mithun. We'll let you know. It's not been required. We'll let you know. After the session, you can go for the support, and I will help you to solve the process. We'll have the session, and on my cluster, we'll show you all this configuration. All right. Thank you. So, what we discussed last session, we talked about. Okay. So, this is what we discussed about a name node. We'll talk about data node. We talk about secondary name node. These are the components that store the data on HDFS. That's the logical database of Hadoop. Right. We talk about the master-slave architecture. What all the masters? Can I get a quick response in the chat window? In the master categories, what we have to talk about. So, what you talk about the master? We talk about the master categories. We have a name node. We have a data node. We have secondary name node, right? And the slave part, what we have a job tracker, sorry, we have task tracker, and we have data node. This is what the category we have. Above this all, this is what's called Hadoop daemons. Remember, and Hadoop terminology is very, very important. So now when I'm talking about the master, you should know what I'm talking about. When I'm talking about slave and I'm talking about daemons, there's all three different categories that we have. Okay. We some talk about physical split. How SDFS different from other stores? So we talk about SDFS. The first point was how it's stored. It's a master-slave architecture, right? The master-slave architecture. Second, what we talk about, it is a distributed file system. Okay. Third, we talk about store the variety of heterogeneous data, and variety of data it can store. Okay. Heterogeneous data we have. Now, how SDFS has been designed, that we'll talk about. Physical split, that is what we have. Physical split, which split the data into blocks. That we talk about the block size by default 64 MB. Okay. We talk about the standard block size what we have in production. By default, it's 120. 64. We talk about the standard block size what 128 MB. We talk about the fault tolerance. Fault tolerance is what making replication factor. So in case data not get down, we can recover the data. So that's by default 1. We talk about replication factor, which is standard in production we use generally 3. Okay. So this is all about the discussion that we have. So let's have a quick some more limitation of HDFS. We have some limitation, and it is very important to know. Limitation of HDFS is all about the principle of HDFS on which it works. The principle say I work on one principle. Write once, read multiple. Means in HDFS, data cannot be modified. You can write on. Data once in HDFS, it cannot be modified. Okay. No update being there. Means Hadoop does not support real-time transaction. This is not good for the real-time transaction. I believe you understand. Like if you're working up OLAP, if you're working on HDFS, then it should good for OLAP. OLAP, online analytical processing, where the bulk data is being processed. All right. So this is what we have on which way you work. That is what we call the online analytical processing, where we process the bulk data. So we'll get the better results. It is not good for OLTP. No update. It is not good for OLTP, you can say. Online transaction processing, where the data is being modified or updated. So this is what the limitation we have. So for this limitation, what we have, that's why we are using, we talk about Hadoop ecosystem. That is one of the external database we have. How to come out from this problem? That we use external database in Hadoop. That is what called HBase. HBase is NoSQL product. So Hadoop take the help of NoSQL in terms of HBase, which support the OLTP or the modification can be performed. All right. So you have to think in mind what is the business requirement. Does it require batch processing? So the complete batch processing will be running on to OLAP. Okay. And okay, complete batch processing is going on to OLAP. But if you're looking for OLTP, parallelly you have what? HBase. HBase is good for, you can have update or modify. Right. This is what the first limitation we have. Now if we talk about some more limitation, right? So the other limitation is say what? It works on high latency. It works on high latency, meaning again, you cannot read or write data randomly. You cannot read or write data randomly in HDFS. So the challenge is data once written, neither you can modify nor you append a new record. For example, in a table we have 100 records. After that, we want to insert, append 2 more records. Not possible. We cannot read, we cannot write the data randomly. Data once written, you cannot append a new record into that. This is what the limitation we have. Or else, data you want to read, suppose in 100 record, we want to read the 78th record, we are putting the somewhere cloud. It is not too possible. So say that you are expecting me to get the high throughput. So for that certain condition, I will read the data from top to bottom. All right. So I will read the data from top to bottom. Meaning is again, HDFS is not good for read or write data randomly. If you're looking for read or write data randomly, you can come again with the HDFS. So what are the certain limitations we are finding with HDFS? We are getting into HDFS. update OLTP, read or write data randomly. We can read or write data randomly. Okay, this is what we have. We can do it. Hope you understand. Let me get a quick response on the chat window. These are the certain limitations we have that we are going through. Say hi, Praveen. I request you please write me in the chat window if you have any question, query, or else if you want to come on here, we'll have a discussion on that as well. Okay, so these are the certain limitations that we have. Now, some good points about Hadoop. It supports commodity hardware, supports commodity hardware. Commodity hardware means low configuration machine. You can put on the low configuration machine, and you can start working on that. Right? It not support a RAM or some high configuration on your laptop, on your machine, 1 GB, 2 GB RAM. You can easily support and you can easily write it. This is good for this job. Commodity hardware, and one we have central limited. It's a Linux Unix hard interface. 1.x is platform dependent. So what we have only Linux or Unix interface that we need to work. Okay. All right. So this is what the commodity hardware. It's a low configuration machine, and the platform Hadoop 1.x is what? Platform dependent. It supports only Linux or Unix interface. So we are working with Ubuntu, CentOS, Red Hat, Linux. In production, generally we are working with the CentOS or Red Hat. Remember, for this session we use Ubuntu as well. We have the Cloudera CDS 3, 4, 5. We'll see. In CDS 4, 5 we have using CentOS, and in CDS 3 we have Ubuntu. So all are flexible to work with Hadoop 1.x. Okay. Now, so this is what we have. Okay. This is all about HDFS that we have. All right. So what we'll start today, a quick introduction that we have, and a quick revision that we had the last weekend. Okay. Thank you. Okay. Thanks, Praveen. Yes, Mithun, any questions, query? I request you all the participants, please write me on the chat window. Navin, Praveen, we have two more attendees. Join Ryan. All right. Okay. So I guess some questions. So I'm not clear about the components which you have mentioned as Jefferson Express. Where do this sit in all over the architecture? So, Mithun, what we have, we just discussed. Let's see here. We go back and do some slides. So where this sits and all depends upon the cluster method. So I will come back on this. There's just an introduction about this part. So depends on the kind of cluster which you are joining. Okay, that you have what kind of cluster that we'll discuss on this. It's just about the introduction that we have. So when we talk about the cluster, what exactly the cluster and where exactly it resides, that's what we are going to discuss today. Is that fine, Mithun? All right. So, I guess Mithun, you have mentioned that I'm not clear about the components. So okay. So yes, it's a weekday session, Navin. So I'm not clear about components. Component, I believe we discussed. This is what all the components we have. I just let me go back to my. So these are the components that we discussed about. We have a component that is an SDFS. In SDFS, we have a name node and data node. And MapReduce, we have a job tracker and task tracker. Okay. So let's make it again on this part. Okay. This is what we have discussed about. Okay. So we have a two components that is SDFS. Okay. We go back. So this is what we have SDFS. SDFS got the two component that is what under the Hadoop we have a two component SDFS. SDFS having the three component name node, data node, secondary name node. Uh, will MapReduce. We have a job tracker and task tracker. So these are the five components that we have. We talk about the master. If we talk about the master component, name node, secondary name node, job tracker that comes under master category, data node and task tracker that comes under your slave category. Okay. Okay. So let's talk about the cluster. These are the components we have, and we understand the rules and responsibility of this daemon. Now, if we talk about what exactly the cluster, we have a different way to set up Hadoop cluster. Okay. So we have standalone. In standalone, what we have, entire cluster is running on a single machine. I will parallelly write these things at my text file. So if we talk about, okay. So here the new section we are starting, cluster. The cluster what we have, we talk about standalone, or local mode we have. That is the first way to design the cluster. That is another pseudo mode, and another one is what called fully distributed mode. That is on the screen as we have in the slide as well. Fully distributed mode. Okay. So what we have, what are the difference we have? Into standalone mode, entire cluster is running on a single machine. Entire cluster is running on a single machine. Okay. An entire cluster is running on single JVM. Single JVM, I hope you understand. Means there's no other daemons are running. Just now we talk about the daemons. What is the meaning of daemons? Okay. This is what we have written. In the master slave categories, what we have. Master name node, data node, secondary name node, slave. task tracker data node, and all this pipe together. All this pipe together, it is what called Hadoop daemon. But in this, there's no Hadoop regular daemons are there, no daemons. Why you are using this cluster? This is just used for development. Yes, if you're working as a developer, in development environment, being a Hadoop developer, you will get a single standalone machine like a developer used to get, like a Java developer having a ID on which it writes this all the job and it writes this all the thing. Okay, so being a developer environment to debug and running MapReduce program. Okay, I hope you understand. It's just used for developing application. Okay, so now what we have next, sudo mode. If we talk about sudo mode, why we use the sudo mode, again, it is set on a single machine. But what is different between the sudo and the standalone? Here all the daemons are running. Your name node is running, your data node is running, your secondary name node is running, your job tracker is running, your task tracker, your all the 5 daemons are running. Let me just check. And all daemons are running on individual JVM. And this kind of cluster we are using for the testing environment. Means what we are learning. We're talking about replication factor. We are talking about the block size. What exactly does it work? So it's a proof of concept. So it's good for the testing environment. What we are learning, just implement and gain you confident. Yes, this all the things are working, and we can implement some POC. So just for POC, proof of concept. That we'll see how to work on. Now, if we talk about fully distributed mode, this is what the real meaning of cluster. Real meaning of cluster means, cluster meaning is what? Group of machine. So what we have here, group of machine, you can see here multiple machines. This cluster is running on multiple machines. Again says, what is meaning of the multiple machine means your name node is another machine, your data node is another machine, means all the daemons are running on an individual machines that we have. Okay, all the daemons are running on individual machine, which is what we are this is what called the real cluster, and this is being used for production. All right, this is being used for production. So we will learn today sudo mode, and then we'll move for the fully distributed mode. I believe all the software is being ready, so we'll help you to design this all the things on your machine. But we have to learn the concept, what the configuration file is being required. So configuration tuning, there's a 2 kind of tuning is being performed to get the performance of the cluster, to get the best effective result, optimized result. So there's a one thing that's called the performance tuning that is being done from the developer end. One is called configuration tuning, and that is being performed by the admin end. Okay, so we'll see both how to achieve the performance tuning, that is in the module 3 in the MapReduce, and then we'll talk about configuration tuning. We'll discuss some part of configuration tuning and designing a basic cluster today. So let's have. Let me go back to my slide. So this all the things are coming in your machine. That is what we have: standalone mode, sudo mode, fully distributed mode. This is all we have for today's session. And We'll design to your pseudo cluster, and parallelly we'll learn the concept how to design the multi-node cluster. But what are the prerequisites required to design a cluster? Where the location and all the part that depends upon the kind of cluster you're using. If you're talking about standalone or pseudo mode, this all the components are running on a single machine. Okay, but if you talk about production, that depends upon your cluster. You can put the data center is the kind of thing. All right, and it can be data center. You're all the one data center having a number of set of data nodes. So that all the location, geographical location at the time of design the cluster, you will decide in production whether you're giving the services. Like in India, actually Facebook is being getting service. They put the data center. I believe it is in Hyderabad. If it is in Canada, giving the service, they put the data center up there as well, which they have a million data records are coming at a day. So this is all the local server they're putting on based on their geographical and their basic requirement, business requirement. They allocate this all the daemons. Okay, so we'll see one by one what we have. Now, fully distributed mode, multiple machines. So prerequisite for cluster. If we talk about the prerequisite of cluster, just one second. Prerequisite to for Hadoop. So to design a cluster, what are the things required? First of all, software. If you talk about the software to design Hadoop 1.x, okay. So software is what we required here. Of course, operating system. It is your Unix and Linux operating system. Okay, Unix or Linux. So you can in production what we are using CentOS. All right. You are using CentOS. You are using Red Hat. We can use Ubuntu, not in production, but for learning and practice purpose, we can use Ubuntu as well. So we are using here Ubuntu. Now, of course, the framework is written in Java. They require GRE 1.6 or 1.7. It can be used. And of course, the third one is very important, Hadoop Image, Hadoop Transfer 1.x. So design any of the software, any of the cluster mode. Right. This is all we have. So this is all the software required, no matter whether you are doing for standalone pseudo or fully distributed mode. Now, what we have after this, after this configuration, now, after this software, if we have, we will design the cluster. So to design the cluster, let me have design the cluster. We talk about designing the cluster. What we have. First, we'll talk about the configuration. Configuration. So in configuration of operating system, we have FreePass, Bash RC. and host name. Okay, let me write it. We'll come on this part. Just let me complete host name. And the third file is recall host. Host. Right. These are the three softwares required, three basic configuration required in operating system. If we talk about Hadoop, what all details required? We have a three directory, conf, which is a very major directory, where major configuration done from the conf configuration. We'll see in the cluster as well. Bin directory, bin, and what we have. The third one is called lock. Okay. JVM is Mithun what we have, Java virtual machine. Okay. On which the compilation is being done. Okay. All right. So the framework is written in Java. So we require the GRE JVM that is support Java virtual machine, which take the bytecode and compile it and convert in the machine learning machine language as well. All right. Now this is what the configuration it requires. Among this, the major is what configuration. Okay. So host name, if you want to give the machine name, right? This is all when we'll use this all the parts of the file in operating system. We'll show you this all the bash assets, the very basic file of the Linux which we use to define the IP address of the multiple machines. If you're making the fully distributed mode or the if it is a single machine, it requires the host name. That's it. Okay. When we'll do this configuration, we'll talk about the major concern is about the configuration. Okay. So let's talk about the configuration. So the agenda is what? The agenda is what? We have to design a cluster in which this all the five daemons should be running. Name node, data node, secondary name node, job tracker, and task tracker. Okay. Right, sir. So let's start from this part. If we talk about how to design a cluster, first of all, you have to go to the Hadoop conf directory. We'll go to the Hadoop conf directory. Inside Hadoop, what we have the conf directory, and the first file is what we have called Hadoop-env.sh. This file is being used to set the Java path. Okay. Yeah, just forgot. Wait. Okay. So that is what we have. This is the configuration file Hadoop-env.sh, which is being used to set the Java path, core side XML, name node, mapper side XML, job tracker, master, secondary name node, slaves, data node, SDFS side XML, replication factor, block size. We used to set the metadata path. After doing this complete job, we will run this command Hadoop node format. So what exactly when we run this command, what will happen? It will generate namespace ID. Look, it will generate ID. Now you say what exactly this namespace ID? This ID is being referred to the metadata that is being a namespace which we have. So we find that what are the components we have? We talk about let's have a quick part. We find that name node is maintaining the metadata, right? Who else maintain the metadata? Your data node also maintain the metadata of only its own data node. Remember, of only its own data node. So we have data node 1, we have data node 2, right? Multiple data nodes. So it all store the metadata. Data node 5, we have a data node 6. It's all having the metadata which maintain its own metadata. The global metadata is being maintained by whom? Name node, which having all the which data is stored in which location. That is all the data node. Global metadata is being maintained by the name node. But if I talk about what are the data you have, what are the blocks on this particular data node, this data node maintains its own. If I ask, do you have the metadata of this data node? No. Every data node having its own metadata and it's independent to each other. Who else maintain the metadata as well? Global. We have secondary name node as well. Okay. So this metadata is being referred one ID we have. So which ID? Right. So this ID, right. So this will generate a namespace ID which refer to the metadata, this ID. So this once this ID is being generated, this ID will be generated by the name node. So when you run this command, it will generate this namespace ID. Will show you this ID as well where it is being generated. And once this ID is being generated by the name node, all other data node also copy this ID. Right. Whoever maintains this metadata will copy this ID which is being generated by the name node, to which it will refer its metadata, which is having different metadata on different data nodes, but ID should be the same. So name node will be asked, kindly generate the ID, and once name node will generate this ID, other data node and the secondary name node, other daemons will copy this ID. Once this ID is being generated, they start maintaining, they start storing its own metadata. Okay. Second, let me come. What other job is this? Once you one, it will generate the namespace ID. Other, it will generate the metadata directory as well. It will generate the metadata directory as well. Now you say, what is meta directory? Look, name node maintains the metadata. That is clear. Name node maintains the metadata on the disk. That is also clear, right? But name node maintains the metadata on the disk in two different directories. That is what called FS image, file system image, and one is what called edit log, which is also called the transaction log. These are the two different directories where the name node maintains the metadata and putting this all the data into its own disk in two different directories. So when you generate this command, when you write this command, this all will created automatically. We'll see. This all will created automatically, which is very, very important. Without this part, you cannot start the cluster. So this is the first command. You have to generate the metadata directory. You have to generate the namespace ID. And then once job is done, then you will start the cluster. So how to start the cluster? You will write start -all .sh. Okay. You will write what? Start -all .sh, which will start your all the daemons which you have designed in the cluster. Now, it is very important to check whether all the daemons are running or not. Maybe that these are the daemons which we are expecting, that all the daemons, name node, data node, secondary name node, job tracker, and task tracker. This all the daemons is expected to run to store across data. But it may be, so it may be every daemons are independent to each other, right? It may be that one daemon is not running, or two daemons is running, four daemons, whatever the five among this five. It is not mandated that all the daemons may be run. It should be run, then we start, but because of some issue, it might be not running. So how to check the daemon status? We'll see here. We'll write sudo jps, or simply write the jps. Java process server, it's a Java command, which is being used to check the health of the, to check the daemon status. Check the daemons That's it. Check the daemon status. That's it. And when you start working with this and you say that, you might notice that this particular daemon is not running. If all the daemons are running, when you write this JPS, it will display what other daemons are running in the cluster. If all the daemons is running, that's fine. In case if any of the daemons is missing, it is not running, you just go to the third directory. That is what? Hadoop log directory. Log directory, just now we have discussed it. Okay. So this is what we have. We talk about the conf, we talk about the bin. Now let's talk about logs directory. So in this logs directory, what we have, when you go inside the log directory, for every daemon, file log will be generated. So suppose name node is not running, you open the log of name node and see what exactly problem you're facing. Okay. So if you find that this kind of challenge, that we come to the log and check it what exactly the problem, and you can solve the problem. It may be the syntax, you may be not configuration file properly. Okay, it can be any reasons. In production, what exactly it happens, they work with the log. If it stop working, they check the log and they find out the issue that behind that the daemons is not running, and it works on that. So this is all about starting the cluster. If you want to stop the cluster as well, we do not stop the cluster in production, but if you're running on cluster on daemon, or sorry, sudo mode, or on one machine, so how to stop the cluster? This is what the command we write: stop hyphen all .sh. Is that clear? Okay. Can I get a quick response to the chat window? All right. Now I'm on chat window. Now let's see. No any questions till now? Yes, guys. You can write. So I get a quick response from Navin. It's clear. Thanks, Navin. Yeah, Mithun. Pravan. Mithun is saying it's very difficult to. Yeah, Mithun, can you explain it? What exactly you're finding in this problem? Uh, so, Mithun, what we have is just all the things which I'm writing theoretically. Okay. This is all the things we'll do the practical. Okay. So these are the steps we have to design a cluster. Okay. So there are three different ways to design to set a cluster in sudo mode, standalone. I have mentioned here as well. why we are using this cluster. For development or purpose, we are using this. For pseudo mode, we are using this kind of cluster we are writing. For production, we are writing this all the cluster. Okay. So first of all, these are the softwares we require to set up this. Okay. And then we'll go to the configuration file. These are the softwares we have required inside the Hadoop. We have this configuration, con directory, bin directory, and the log directory, which we will write there. Then we'll go for the Hadoop con. Inside this Hadoop con, we have to enable this 5 daemons: name node, data node, secondary name node that we have discussed. What exactly name node, data node, secondary name node, job tracker. And then we'll design this all the daemons to relevant to this file. I believe you understand this file. And after this part, we will start the cluster. So these are the steps we have to run the command and check the daemons. Yeah, Mithun? Cluster is the context of the general architecture. So I believe, Mithun, are you familiar with the Java? Okay, to make it more simple, uh, let's write it Java here. Right. I believe it is more clear for you. Okay. Hadoop is written in Java. I believe you heard before this. Hadoop is written in Java. It's a procedural language to make more cluster. So if you're working into development, you have to write coding which support Java. Okay. As well, we have a .NET, Perl, Python, Ruby, C, C++. Okay. So this is what we have. The Java I have written the version. If you're not sure, that's not fine. It's all the software being required. That is already on your machine, which we have written. Okay. All right. So now, you don't need to be panicked for this. What exactly Java and all things. It's all I'm talking about the architecture level, how it is being written and how it's being designed. So we are not using this. We have to not bother about this. The Java, how it is being installed and how to work with that. How the framework is written in Java. We have a different vendors which give you the predefined cluster. That is what we are using today. Of course, it is a big task to design the cluster, but what we are using today, a predefined cluster on which all your softwares, which we are talking about, is all the things which we have right now. Your data node, secondary name node, that's all we have. It's a predefined. Okay, it's all predefined, and we'll show you on the machine. Okay, so we have couple number of vendors which say that use my product. It's a pre-configured, and you can use this. So the vendors names are a number of distributor we have distribution, number of distribution we are using. That is what Cloudera. It's Cloudera. What we have. Another one is Hortonworks. Okay. We have AWS. We have IBM inside. These are the vendors which are giving you the predefined cluster which you work. So what we are using today, if you talk about the enterprise level, what exactly we are using at Cloudera, or you can say Hortonworks as well. Okay, so we are giving you the, if you talk about what is more user friendly, it's called Cloudera. Cloudera is more user friendly. Okay, so what we have today, CDS3. Now we'll request you just open your machine. Okay. The username password which we have, the Cloudera. Are you online? Okay. So yeah, Navin. Let me select this. Start your Cloudera. I believe we have all this. Yeah, Mithun, you are on here.
Hello?
Yes, Mithun, I'm audible.
Yeah, I can hear you. Yeah.
Okay, yeah, go
Just
ahead,
trying to
Mithun.
start.
Okay,
I'm just trying to start Cloudera now.
okay, okay, fine. So before that part, Mithun, can I get a quick clarification from you? What is all your understanding? So what we discuss about right now, these are the softwares we have, which should be installed on your machine, and these are the configuration which required to design a cluster. Fine, method. So objective is what? We are using a predefined cluster. We are not need to bother about this all the part, right? But to be a very clear understanding of the architect, this is what I'm giving it to you. Bring into that these are the files we have and where we are going and writing this all the configuration. Suppose if you are making a tomorrow 5 node machine and you want to make just take a machine name 1 2 3 4 5. You have a 5 machine name is 1 2 3 4 5, and you want to make machine number 1 as a name node. So how you will decide that this machine number 1 should be a name node? That is what the objective, that is what the agenda for today's session, to make you understand to design a cluster according to your base requirement. Okay?
Okay.
Yes, madam.
It's
You
not
can.
very clear, to be honest. I mean, when you talk about these machines, I mean, I saw that you had put down data node 1, 2, 3, 4. How is that actually divided up? What is the criteria for setting that up? And I didn't also understand why metadata is stored in a data node. I thought metadata is stored in the name
Okay.
node.
Okay. Just I make you understand. I will come one by one. Your all the answer. The first question is what you're talking. Why the name node and data node is both maintaining the metadata, right?
Yeah,
Okay. Just understand. Name node is a master, right? Data node is what?
yeah,
Slave. All right.
slave. Mm-hmm.
Understand. I will better come to. Let's see. I believe you can see on the screen. Okay. So
Okay.
this is
Yeah.
what we have. We have one. Let me make it multiple copy of this. Okay. I'll make it very simple. Why it is being required? That's also a good question. One, two, three. I will come back, guys, on your question. I will give the chance to you to come on here and you ask your question. Let me start out this question first here. Okay. One, two, three, four, five. All right, Mithun. So,
Yeah.
and the second thing is what we have. Name node maintains the metadata. All right. Therefore, this is what the metadata. All right. And let me make it copy. So let's. This is all we have. Data node. I'm not connecting all this. Hope you understand. All right. And this is what your metadata.
But why is there so many data nodes? I mean, this is the other question I had.
Mm-hmm.
Why isn't it just one? What's the advantage of having more than one? And
Hey,
you know,
understand. Okay. Okay. It's depend upon you. It's depend upon your basic requirement. Like data node holds the metadata. Sorry, data node holds the physical data, right?
yeah,
Right, sir. So I believe that we have discussed last session as well. I will repeat why this is multiple node we are writing. Okay, look, it is a distributed file system, Mithun. Hope you understand
Yeah.
distributed. So what is going on? I believe you remember. I'm just to make it again. So let's have. So let's have you have a 1 TB file, okay?
Yeah.
You have 1 TB data, right? And
Okay.
this is what user A. Okay. Or let's make it simple. A user A, or suppose this is what my cluster 1, 2, 3, 4, in which I'm putting data node. How many data node we have? Data node 1. I'm putting data node 2. I'm data node 3 and data node 4, right? For example, one name node and
Okay.
4 data node we have. Now, you are saying that I want to use your infrastructure of Hadoop to store my data. Fine, Mithun, you are my customer. So I
Okay.
will take your 1 TB data and I will store into the cluster. Now, let's see why it is being multiple data nodes and why not one data node. And if you put the one data node, what are the disadvantages you can have? You can put one data node as well. That's not a question. You can put it. You are completely independent. But we have some disadvantage. So 1 TB data, I believe you discussed, it will split into small blocks, physical split.
Mm-hmm.
Method, I hope you remember. So this 1
Yeah.
TB data will split into small blocks. Let me make it small block. Uh, right. We discussed this data 1 TB data when you send to me, it will be given to the client, and this data
Yeah.
will split into n number of blocks, and that is what called physical split. That's right. We just talk about this configuration uh, that we have master slave physical split. Right? Take a look. Right, sir. So this is what the physical split. When you want
Mm-hmm.
to store the data, it will split into the n number of blocks. Now the questions again come: why we are splitting the data? Right? I will come back. So this data, it should be split in a number of blocks, and I will write the block name, and the block will, the size of the split that depends upon you want. By default, if you will not define the size of the block, it will be 64 MB. If it is recommended, the block size should be multiple of 64 MB. If you wish to increase the size of the block, you can put the multiple of 64 MB. You can put 128. Now you say if I put it 30 MB, 35 MB, it will also come. But the performance issue you can fix. I believe in production, the two things is very important. Cost effective and the performance. Right, Mithun?
Yeah.
Right. So this is what happened. It is recommended kindly put the block size in production 128 MB. So we'll define the 128 MB. We'll discuss. I believe we have discussed already how to define the block size. Now suppose this is all the blocks we have, which has been split into a number of blocks. Now you say why you have split it into a number of blocks? The reason is how we talk about this is what master slave architecture. Now you say what how Hadoop is unique from other database. Right. This is what we
Yeah.
have. How Hadoop is unique because it's a master slave architecture. I believe if you're an experienced, you've gone through the RDBMS, you never find that database or server is a master slave architecture. It's a single server, right?
Mm-hmm. That's right. Yeah.
Right. So let's understand why this is a master slave architecture. Okay. So we have the agenda was why I split the data because I want to distribute 1 TB of this data, 1 TB of this data into n number of data nodes.
Mm-hmm.
Okay, understand? I want
Yeah.
to split, I want to distribute this all the blocks into n number of into this among 4 data nodes. You can put 10, 20 as per. I'm just using my 4 data nodes. All right. So I will
Okay.
circulate this. Who will decide? Name node will decide. Fine, sir. Who
Okay.
will decide? Name node will be deciding. Okay. So this all the block D. Okay. And it will be, I'm not putting all the blocks for your understanding, I'm putting like this. So let's see,
Okay.
this all the blocks on this. This part is clear why I have splitted the blocks into multiple data nodes, right? Because I want to
Yeah.
split this data onto multiple data nodes. Now you'll say why I'm splitting this data onto multiple data nodes, right, Mithun? This is also the question,
That's right. Yeah.
right?
Mm-hmm.
So let's get this answer for this. So this is all the blocks I have stored onto multiple data nodes. Now, for example, client write a job. Let me add. Let's talk about the traditional database. You might be familiar with the batch processing.
I am. Yeah.
Okay, let's talk about the batch processing and to make it more clear how it works. Uh, okay, so I'm getting June. Why? It's not good. Just give me one sec. Okay, so I'm not getting the proper option. Uh, just give me some minute. All right, now, so let's see what is the meaning of batch processing in your job. What is the batch processing is being called? So I'm not able to open the file. Okay. Anyways, let's come to this part. Okay. Let's move it. All right. So let's have. This is what one we have a server. So a quick understanding, Mithun. Mithun, you are having a one mall, right? In that mall, you're making a n number of transactions every day, right? Right. So in that
Mm-hmm.
transaction, you can have a control from a single machine, right? What the transaction you have done today. Okay. But let's have
Mm-hmm.
an example that you have a business now all over India. You have something 25 or 30 mall that you're running all over India or in US, right? So how you handle
Mm-hmm.
this? You cannot handle manually. So for that you will hire the IT vendor, right? IT
Yeah.
vendors, your companies which you have, like let's take an example. You have you asked to Accenture to handle your account, right? So what they
Yep.
will do, right? So suppose in India one festival is coming. Let's take an example. And what kind of business requirement you will expect from your IT client? You will say that who is supposed to come, right?
Mm-hmm.
And you put 10% discount. You put the 10% discount, flat discount on all over the products which you have. Okay,
Yep.
right. So after Holy Cross, you want to know what exactly the benefit you have. After giving the 10%, do you have profit, right, sir? Or you have a loss? This is the two things it can happen,
Mm-hmm.
right? Or it can
Yep.
also happen. You have in your mall, you are selling a number of products A, B, C, D. Maybe that product after putting flat discounts on every product 10%, you get it that on block and the product A you are having a loss or profit. That is all about. So if you want to take the fair decision, if someone tell you on this particular product you are getting the loss, so immediately you can stop this offer, and on which you are getting the profit, you will start with that, right, sir? This is a normal business
That's
decision
right.
you can take it, right? So to whom,
Mm-hmm.
how you will control this part? So you will ask your IT vendor, write this kind of software, design the application, design this kind of software, so I can evaluate this kind of margin and I can take the fair decision, right, sir? This is what your
Mm-hmm.
business requirement, right? Now, IT vendor will ask its developer, kindly write this job. Okay.
Yep.
So let me one. Okay, you will ask to write a job. Now, let's see how the job will be processed. Now you have a two different server. Okay. In traditional batch processing, why Hadoop comes in the picture and why today IT are more demanded to Hadoop. Let's take an example. So let's say this is the server one. This is the server one on which your business logic is running. Okay. Your business
Mm-hmm.
logic is running in terms of management. We can say the business logic is running. Okay. And let's check this server on your input data. You will ask your client, like I will ask, you hired me to maintain your account, Method, right? So I will ask you kindly, Method, what are the transaction it happens at the end of the day, just send it to me. I will run this all the input transaction on the business logic and I can give you the result, right? This is the objective.
Yeah.
What the business
Mm-hmm.
requirement. So this is the server one and this is the server two. Server one, the business logic is running, and the server two, whatever the transaction you have done, it is stored here. So what I will do, that is at a regular interval, you see that New York Stock Exchange, Bombay Stock Exchange, after 4:30, it starts processing and it will give the final result. Today, what the business you have done, right? So it comes on the batch processing. So at a regular interval, what the interval you will put after 2 hours or 3 hours, let's say 6 hours. So after 6 hours, whatever the transaction you have done, it will come onto this server, and this all the data I will move it to from this server to this server, and I will
Okay.
give you the input. I will give this server as the input. Let's see, the input is nothing. The input, let's take an example. This is your, you have given me input. Example, A is equal to what? 1, and B is equal to what? A 2. All right, and this is the business logic for your understanding. A plus B. I have written. Let me make it more large. Okay. So this is the business logic that you have written. Okay. A
Mm-hmm.
plus B is equal
Yep.
to what? You have C that you have written. Now, what I will do to get the value of C, you require the input value of A and B, right, sir? This is what you
Yeah.
require. So I will
Mm-hmm.
move this input data to the location and I will get the value and you will give me the C value. I will get the value and I will pass to the business method the result. Now you can take the fair decision. Hope you understand.
Yeah.
Okay. Now the problem is what? This was going continuously. This is what called the traditional batch processing. But what the challenge we faced from this? The challenge was, it was very simple. Let's check 100 TB of data that you have to process, right, sir, on a single server. That is what the single server on which you have to process 100 TB of data. Do you have any idea how
Mm-hmm.
much time it will take? If you are processing this data onto RDBMS, why today number of projects, now why the number of data are today are migrating to Hadoop? Anyone? Navin, Kevin, Rajesh, Akash, why n number of projects or why the demand of Hadoop is getting day by day more? It's very simple and short answer. I'm giving you very fair, clear picture why today. So just now, let's see. This is the data which Mithun is passing. It's generating suppose 100 TB of data, right, Mithun?
Yeah.
And you might be getting, it is clear. You might be getting, for suppose on 100 products, you might be getting 30 products. You are getting the loss, right? So it is
Mm-hmm.
getting lost, and you will be expecting from the client in from me, as soon as you will give me the result, I can take the control on the business, right? Fine, sir. I can stop it
Yep.
immediately. Whatever the 30 products I'm getting the loss, I can stop it. But what all these products you are waiting for my result? This is what we have. So till that I'm not giving you the result, you do not have the control on your business, right? So what happens
Mm-hmm.
if you are giving 100 TB of data and you are asking to RDBMS to process data? It will take couple of days. It can take a 1 month as well, depends upon the server you're using. So till 1 month
Yep.
job is running and it you are waiting for that. After 1 month
Mm.
you're getting the result. So after 1 month, what are the loss? You do not have the control, right? All right, sir. Now what
That's right.
happened? Some other client comes to you, some other one comes, say, Mithun, why you're waiting for a month? I'm giving you the result. You just give me your data. I will process the data and we will give you the same result in couple number of hours. Will you accept this proposal?
Yes, of course.
Of course, why not? If someone is giving, because we do not have the business control, we do not have the option. The client is giving you 1 month time, and someone other client is saying, giving the proposal, I'm giving the result in 1 hour. So why not? But let me test it. How you can make this? So he's saying that I'm a Hadoop cluster. I'm processing a job onto the cluster. So how you achieve this result? What my client is giving the result onto 1 hour, 1 month. How you can expect the result is coming in 1 hour? It's a very simple. Look, this is what my architecture. And let's say the size of the cluster is what? 100 data node, right, sir? Fine, Mithun. This is what I'm talking about. This is what the four data node we have. Let's talk about data size is what? 100 data node of cluster. So when you send the data, 100 TB of data, 100 TB of data will what happen? It will split in n number of blocks, right, sir? In HDFS, how it split data? Why I split data? Because I want to put this 100 TB of data across 100 data nodes. I hope it's clear, right, sir?
No, I don't. Why 100 data nodes? I don't understand that bit.
Okay. Let's check. Okay, I'll give you the good example. Let's take example of 100 data node, right? Okay. So if I take 100 data node of cluster, so after splitting 100 TB of data, you will get the n number of blocks, right, sir? Right.
Yeah.
Means 100 TB, how many number of blocks? Divided by 128 MB. You will get n number of blocks. And this block will be circulated among 100 data nodes, right? Right, sir? And in Hadoop, what happened? In Hadoop, what happened? In your business logic which you are running, in your like previous batch processing which you are running, okay, like this is what your RDBS which is saying that I'm giving the result in one month. How that job is running? Input data is moving to the location where the business logic is running, right? But in Hadoop, how it works? Hadoop say what? I will not share my data. I will not share the data. You share your business logic. Means you share your business logic. This is the logic I'm talking about. A plus B is equal to C. Right? You share your business logic to the location. I will execute this business logic to the location where my data is available. All right. So what happens when this business logic? Let's take an example. This is the business logic you have, right? So this business logic will be, when you sending to the cluster, it will be running onto, let's make it copy of this. So what will happen? This business logic will be running on every node where you distributed the data. 100 TB data, wherever you have put into the multiple machine, it will be running. Great. Clear, sir? So do you have any understanding what exactly is going on? It's a parallel batch processing. It's a very simple concept. One person was doing the complete job, right, sir? One person was doing the complete job in 10 days. Now the work has been distributed into multiple person. You increase the number of person. You hired a 10 person, and you distribute the complete work among divide the work equally to the 10 different person. The complete job will be done in a one day. Is that possible? It's a simple time and work concept, right, Mithun?
Yeah.
Right.
I mean that makes sense. That makes sense. I mean the question is why not then 1,000 data nodes?
How many?
1,000 data nodes is what's the
1,000 data nodes.
restriction here?
That's fine. That is what I'm talking about. So let's say as number of data nodes. So if you put 100 data nodes, time will be taken. You know how much time it will take to process 100 TB data. It will take 1 hour. Okay. Now you are saying to increase the data node size. Yes, you can do it. No problem. It's your cluster. You increase the size of the cluster. 200 data nodes. The complete job will be done into 25 to 30 minutes. Hope it makes sense.
Yeah. It does.
Got it, sir? 25 to 30 nodes, 25 to 30 years. Yes, your cluster, you define what is the size of the data, you can decide and you can work with that. I hope it is clear.
It is, yeah, I understand.
Okay.
So this enables parallel processing, yeah.
Exactly. This is what called the parallel batch processing. This is how Hadoop. Now it makes sense why I split the data, because I can run my job onto multiple data nodes. That's why I've split the data onto multiple data nodes. So all and every data node is engaged to process 100 TB of data. As
Okay.
many number of data nodes, as less it will take us some time to process the data. So that's the Hadoop. To achieve the high scalability, we are frequently migrating data to RDBMS to Hadoop.
Now, what about if the file size is only 64 MB? Would that just go into one data node then?
Of course, it's a one data
Because the
node. It's a one simple.
okay,
It's a one data node.
because it's only
Right.
one block. Okay.
Right. So that's why it is recommended, don't process small files onto Hadoop. Hadoop is not good for the small files. It's for the big data.
Okay.
Okay. It will process, but it not make sense to process 64 MB of data. You have RDBMS, you have another tool, you can process it easily on that. So Hadoop is
Yeah.
recommended to go for the big data. All right.
Okay. Yep. Makes sense.
Okay, that's all the questions. Now, I believe now you understand this all the configuration on the part. Can I get a quick response from other participants who are in the session? Yes, Navin. Let me go with them and ask them one by one. Okay, so I guess. Okay, started in analysis. Yes, Pravin says faster analysis of big. That's why Pravin is a yes, it is clear. Thanks. So what is Mithun? That's why Hadoop is demanded now. The work which you are taking in the 1 month, now it can be accept in the 25 to 30 minutes, and it can be come into 1 hour. Depends upon the size of the cluster. As you increase the number of cluster size, it will take less time. Now you talk about, do you have any limitation of nodes in the cluster? Yes. Now the questions come here. You might be remember we talk about we have Hadoop 1.x and 2.x, right, sir?
Mm-hmm.
Right. 1.x say
Yeah.
what? 1.x say what? The size of the cluster, it cannot be exceed more than 4,000 nodes. Right.
Mm-hmm.
The size of the
Yeah.
data cluster cannot be exceeded by the 4,000. If you increase by 4,000, the efficiency will stop. It will stop working. It in the efficiency, it will impact the performance of the cluster. So that's why we stick with the 4,000 node of cluster. Now we come with the 2.x. 2.x said what? The your what? Limitation of it exceeded by 10,000 node of cluster. You can put a 10,000 nodes of cluster of a big cluster it can be. This is why we prefer Hadoop 1.x to migrate to 2.x. Right, guys?
Okay. Yeah.
All right. So this is all about for the cluster. Methun, all of you, can I get a quick response from your end? Okay, thank you.
So I had the question about why the metadata is stored in a data node.
Okay. Okay, great. Okay, I think I might not get the time. Okay, let me clear this also.
No, I mean, if you don't have the time, it's okay. You can do
No,
it
no,
later.
that's fine. It is very important to go with the concept as well. Look, what happened, Methun? This is what your name node, right? This round circle. Let me. Sometimes I check with my machine. So this is what your name node, right? And let's
Yeah.
see, what are the blocks we have? This is the block A, right, sir? We talked
Mm-hmm.
about the replication factor as well. Like name node
Yeah.
maintains the metadata, right? Hope you're clear.
Yes.
We
Yeah.
have one more component, that is what's called secondary name node, right?
Yes.
Remember the secondary name node? If name node logs the metadata, who will give the backup?
Secondary
Secondary
name
name
node.
node, right? So in our
Yeah.
cluster, we are storing two kind of data. We are in our cluster, we are storing two kind of data. One is metadata, one is actual data. Metadata has been
Yeah.
maintained by the name node, and
Name node.
actual data
Yes.
has been stored by the data node.
Data node.
So
Yeah.
if if your name node log the metadata, who will give the backup? Secondary name node. But in condition, if this data node, if it stop working in this cluster, if this data node, if it stop working, right, sir? If it stop working, do you have any backup? No, right, sir? This
But
is the
if you have
block that.
replication, you might have backup, right?
Right. Now you're coming on the point. Exactly. So this is what your data node, if it lost, what you lost, the block C. This is the block C. You can lose this
Yeah.
block, right? So do you have backup? No. If one block data is being read, means it will affect all the data which you have stored. So now what you have, you are going with there's a terminology that is called what? Replication factor.
Yeah.
I hope now you understand, right? Now that is why
Okay.
replication factor, let's say, replication factor which say by default it is what? 1. 1 means
One.
all the blocks will have only one copy. Let me go back. Okay. So A, what we have? We have B, we go C, we go D. Okay. So
Yeah.
what we have? Replication factor A, 1 means there's no backup, there's no copy of the blocks we have, but we cannot survive with this. So you can put n replication factor. You can make it 10, 20. But what is the standard we are writing? 3. Let's make it 3. 3 means all the blocks will copy how many times? 3 times.
3 times. Yeah.
Okay.
Across all the data nodes. Yeah.
Right. Now let's make a replication. Let's make a replication of this C. Okay. Let's make only one which you can understand. So I will make it C. So let's C is stored here, right? I'll just copy of this C. Okay. So make 3 copy of it. As C1 is here, C let's make it here, right? Who will decide? That name node will decide. Okay. And let's C put it here as well. Okay. Fine, get now, and it will maintain this, right? C, what are the C copies are stored? C are stored onto data node 1, C are stored onto data node 2, C are stored into data node 4. Right. Now let's make it more clear. Now let's make it more clear. Now, for example, now this data node goes on, right, sir? This data node goes on. Now you will say you have a backup, right? You can get into work with that. But one thing is very simple. Okay, you are making a backup. That is simple. That is fine. You go with that. Replication factor 3 means. Now, if one C goes on, it's fine. But tell me one thing. There something goes wrong. Something wrong is what? Okay. According to this factor, I'm making all the blocks 3 copies. Okay. And the current status is what? Data node 2 is gone, and on data node 2 we had a one block, that is C. So according to that, number of blocks C is available 2 only, but we can work on that. But the statement is wrong here. Something, this replication factor say what? By default, no, sorry, the common replication factor, the common block, number of blocks for every block. The replication factor is common for all the blocks, right, sir? But here the statement is wrong. Replication factor for blocks is 2. So we have to maintain the replication factor here as well. Reason, if suppose we had 3, right? If it stop working, now we have what? 2. Again, if sometimes after sometimes it 2 goes on, right? Again what we have? Single. Again single point of failure. In any case, if it goes on, do we have any? No. So it's very, very important to maintain the backup of to maintain the replication factor. So it is what happened. It is said whenever any data node, whenever any block, whenever any data node, if it stop working, all the blocks which is stored on this particular data node will be shifted to the active data node. Am I clear? I repeat it once
No,
again.
I don't know. What is an active data node?
Active data node, what are the active data nodes? This is what active, how many data nodes we have? Let's say this is the data node 1, this is the 2, this is the 3, and data node 4, right? So currently, how many data node is active? Data node 1, 2, 3, 4, right? Now data node 3 goes down, right?
Yeah.
Right, sir? Data node 3 goes down. Now how many active data node we have? 1, 2, 4,
3.
right, sir? Yes. 3 by numbering is 1, 2, 4. So what will happen here? It is said to maintaining the replication factor, no, all the time the replication factor should be 3. So for maintaining the replication factor, they come with the one principle. It is said whenever any data node, if it stop working, suppose data node 2 get down. Okay, let's make it. We have a 4 data node, 1, 2, 3, 4, and which is live. Now we have only 3 data node is live. 1, 3, 4. So it is said whenever any data node, if it stop working, all the blocks which is stored on this data node, currently on data node 2, which blocks we have? 3,
Three.
right sir?
A,
All the blocks, whatever A, B, C, D, all the blocks which is stored on this particular data node, which currently it is dead, the stated is dead, it will migrate to on other live node. Understand, sir?
Okay.
It will
Okay.
migrate to on the live data node. So on which data
Yeah.
node? Let's figure out. Let's figure out. Can we put on the data node 1? No. Already the C block is stored. Replication cannot be happen on the same data node. Keep in mind. So can we put on the this block on C? No, C is already there. We cannot put the replication on the same data node. So 1 is not right option. Can we put on the C?
No.
Yes, 3 we can put it, right? We can put on 3. We cannot put on the 4. 4
Ah,
already we have,
yeah.
right? So
Yeah.
what
Okay.
are
Got you.
the option apart from 1 or 4? Apart from 1 or 4, you have a 10 data node. So apart from 1 or 4, what others? Or currently, what is the status? We have a 4 data node. So 1, 4 is not the right option. We can put into the C. Clear, sir?
Yeah. Okay.
All
Yeah.
right. So now what we have, the replication factor earlier it was, now, sorry. So what we had earlier it was 2, now it maintains, sir. All you agree? It is maintained now. Yes,
Yeah.
please. Can I get a quick response?
Yes.
So this is how we maintain the replication factor. But the question is again, it's still something is unbalanced. You can see on the screen and you can answer me. Something is still unbalanced. You can see here. Can anyone answer me what's still unbalanced here? Okay, let me open. Something is still unbalanced. You can say here current status of C. C are available on which data node? C are available on 1. It is written C on available on 1. C are available on 4. C is available on 4. But C is not available on 2 because 2 is dead. C is now available on to third. So we have to update my metadata as well. Got my question, sir? Got my.
Okay.
We accordingly, because the block location is not fixed, right, sir? Block location is what? It is not fixed. So accordingly,
Okay.
if this block migrated to, if this block which we have on the data node, the block which we have onto this, now block location is not fixed. So accordingly, if it is not fixed, we have to update this as well, right? So if it moves
Okay.
to this part, the current status should be what? This.
C3.
Exactly. Now this is the question, how it will update its metadata. Got my question, sir? Now I'm coming to
Yeah.
your answer. Why the name node should have, why data node should have the metadata as well. Now the question, how, there's a one question, how name node maintains the metadata? There's a one question. Now, there's a communication between the name node and data node, right guys? There's a communication between the name node and data node. Name node come to know that architect is something like this. If any name node, if any data node, if it stop working, the block will move to the another data node. On which data node, accordingly, I have to maintain my metadata. This is what my job, name node job. And name node has to keep in mind this part as well. It has to mention that the data node which is stopped already, I should not assign the work. Now it is not the part of the cluster. Got it, sir? Right. Name node has to update its metadata and it should be the data node which has stopped working, I should not assign the work to that particular data node. So how name node will control on these two things? Right. So what will happen? There's a communication. It happens. Suppose it's very good example. Like in this session, 10 people are there, right, Mithun? Okay.
Yeah.
I should know you all are live in the cluster, right? A very simple and very interesting one. I should know you all 10 participants which you are listening me are live in the cluster. I said what? how should I interact you? I say what? After every 1 minute, you have to write me on the chat window. I come to know that yes, Mithun, you are live in the cluster, right? Live in the session, sorry.
Mm-hmm.
Right?
Yeah.
I equally I keep contacting you, right? Whether this person you, Mithun, you are available or not. So I should know whether you are in the session or not. The same way,
Mm-hmm.
what name node say, you all the data node is live in the cluster or not. How should I know? So name node say you have to send me a notification. Okay, at a regular interval. At a regular interval, you have to send me a notification, and that notification is called what? Heartbeat. All right.
What is it called? Sorry.
Heartbeat. Heartbeat. It's a simple signal which will be sent by the. Let me show you. Right. It's a simple signal which will send by the
Okay.
every.
Data node.
Right. Every data node has to send a signal after every 3 seconds. It's
Okay.
a default time. If a default, you can increase the time as well. Let's see. So every 3 seconds, I should get a response from your end. If I don't get the signal after 3 seconds, I will assume you are dead in the cluster and I will not assign you work. Clear?
Okay.
Okay. So according to this, data node is sending the signal, but now what happened? It is not sending. It is dead, right? So it will not
Mm-hmm.
assign the signal, not is a part of cluster. Clear? One point
Yep.
is clear. Our name node should know whether the name node is active, which data node is active in the cluster or not, by the sending the signal. Okay, this part is clear.
Yep.
I did not get the
Yes.
signal, so I declared that you're not now part of the cluster. Now the second thing, name node know this as well. If any data node, if it stop working, the block of this node will migrate to the other data node, right?
Yep.
So currently the block C is moving to the data node 3, and accordingly I have to update my metadata. So how name node will control? It is said what every 10th heartbeat. It's better to write this all apart. Alright. So okay, let me write this all apart. I will send my the docs as well. I'm going this way. Okay. Communication between the name node and com you understand between name node and data node. Okay, I have certain slides for this. I will share with you guys as well. So what it will say, every 10th heartbeat, right? Sorry. After every 3 seconds, every 3 seconds, data node has to send a signal to whom? Name node. That is what called heartbeat. This signal is known for whether the data node is live in the cluster or not. If it is not live, it will declare dead, if not get the signal. So accordingly, if any data node, if it stops working, the block should move to the data node and another data node. Now the block which we have data node 2, it has been shifted to the other data node. This is on the data node 3, right sir? And
Yep.
accordingly, now name node has to update its metadata. This is the objective. Now how it will update it? Let's see. It is said every 10th heartbeat. Now, how name node will update its metadata? It is said what every 10th heartbeat. 10th heartbeat, what is the time? 10th heartbeat is what? 30 seconds, right sir? Means what the 10th heartbeat which data node is sending to the name node. It is what called block report. Block
Okay.
report is saying what? Current status,
Active.
right? Current status of block on particular data node. Now understand, means every data node will maintain its metadata as well, right? So let's see the 10th heartbeat which send this particular data node 3, it will say on my data node currently a new block has come and this is what my current status of my metadata. So kindly update your metadata. So once it get the signal, it will send the 10th heartbeat and it will say the particular this data node having the new metadata on its own data node and the block is what? C. So it will write here C is what onto. Yes, Mithun, it is clear now.
Okay, so what I wanted to understand is this is basically sort of process metadata in normal data warehousing terms or relational database. You'll call this process metadata. So it's not actual metadata of the data that's being written on the name node, if that makes sense. I mean, I'm talking
Uh-huh.
about the actual data.
No, actual data, look, metadata is nothing, the location addressing. That's
Okay,
metadata means
that's fine.
data of data, not actual data.
No, I
Metadata
know that.
means,
What I'm saying,
uh-huh.
no, I know that. What I'm saying is that metadata in this case is actually the process metadata is being stored here on the name node. Yeah,
The
it's
location of
not the metadata.
location of
It's
the
not the
block, simple.
actual. Yeah, it's not the actual data about the data. It's actually the location, etc. Yeah.
Exactly. So this is what the
Okay.
current status which name node is getting and how it is maintaining its metadata. So that's why it
Okay,
is
that makes sense.
right. It is mandatory that every data node has to update, has to maintain its metadata, and at a regular interval, it will send the heartbeat that is called the block report, and it will say currently on my data node this number of blocks are available. So currently update your own metadata by the help of my block report. And the block report is nothing, it's the current status of the block location on a particular data node. All right,
Okay. Yeah.
fine. I guess can I get a
Thank you.
quick okay, thanks, Mithun. Any more questions, Mithun, from so till what we have discussed? Yes, Navin. Let me put on to the mic. Yes, Navin, you're on air.
Yeah, I'm good actually. Yeah, I did get most of it, so I'm fine, thanks.
Okay, okay, fine, Navin. It is clear for Pravin. Okay, let me just. I guess first it's fine. Okay, let me make it some more people on here. Yes, Pravin, you're on here as well. I hope you have mic with you. Okay, it's an office, I guess. So Pravin say okay, that's fine. It's not having. Or anyways. So guys, this is what we have. I guess we have done for today. Uh, so this is all the part. I believe it's fine. We have. It's very important to understand the concept as well. We have some session, but accordingly we will do tomorrow. But it is fine. I believe what we have discussed, the concept and what the doubts Mithun has, it's been solved. And what the part we have covered today, and we were supposed to do the practical, will start by in the next session. Yes, Mithun. Any questions till now? Till what we have discussed?
No. I mean, would like to get some notes on this because it's sometimes a little difficult to follow. So,
We'll share this recorded session. Okay.
okay. Yeah.
The session record session will be given to you as well. We'll share some notes as the PPT which we have. This all been shared with you. Don't worry. Okay.
Okay. Very good. Very good. Thank you.
Okay. So all the docs will be given to you. We have the elements on this. The credential will be assigned to you. I believe you have all done the registration. So Utkarsh or Somu will be the contact person. He will be in touch with you regarding this all the docs.
Okay.
And I will request you again, just log into our Skype ID. So use the support number as well. It's better to call if you miss some data or you are having some challenges while installing or downloading the software. Just log into our Skype and ping to us. The support team will definitely help you. So PRWA dot just sending you people PRWA dot TECH. This is a Skype through which you can write you better ping to us, or you can call to your support number 8147111254. The slides which we are sharing today, all the details will be mentioned. You can take the help of there as well. In case if you find any challenges while installing the software on the machine or any docs you are missing. All right, Mithun. Yes, Naveen.
Okay.
Anything from my end?
Just a quick query. Tomorrow's session, is it at exactly 5:30 or 6 p.m.? I got a bit confused today.
Naveen, your voice is not clear.
No, what I mean to say is, tomorrow the session is at 5:30 p.m. or is it at 6 p.m.? I had a bit of time confusion.
I believe you got the timing details at 5:30.
Yeah, 5:30, but then Somu told me it's at 6 o'clock. So,
Regarding this, just should have a discussion because what I've been asked to start the session and the details to 5:30. Regarding this part, Naveen, you just have a discussion with Somu. He will help you in that. Okay.
all right, thanks.
Okay. Thank you. Thanks, Mithun. Hope you see you in the next session. All right. I'll just ask
Okay.
my team as well. They will call you after the session, and what are your if you're facing some challenges, just have a discussion with them. We'll definitely help you in that. Okay.
Yes, please. Okay.
So thank you. Hope to see you in the next session. Uh, thank you, Naman. Thank you, Mithun. Thank you, Praveen. Thanks, Utkarsh. Thank you. Thanks. Good night. Take care.